Tim has a master's in both environmental science and environmental law and has been working as an environmental scientist for over 20 years. He's had almost 2 decades of polar travel, most recently in January and February of this year. On a previous expedition where he followed in the footsteps of Sir Douglas Mawson, he deliberately starved himself to solve the mystery of whether it was necessary to eat a colleague. He got severe frostbite in his toes and had to keep them alive by putting boiling water in his food bowl and then dipping his toes in. And he apparently lost 3 molars because his fillings froze, shrunk, fell out, and he lost his teeth. So he's going to talk about his more recent expedition today, but that gives you a little bit of flavour of what we might be in for. Tim combines his love of adventure with a passion for environmental issues. He's looking for workable solutions to issues related to climate change and unsustainable land use, and it seems that his tagline is "Thinking is good, but doing is better." So today, Tim will talk to us about what he's been doing lately. Thank you, Tim.
A room full of hecklers, if ever there was one. Thank you very much. Look, I've just returned from the Antarctic, retracing Shackleton's journey, and I think Shackleton gets all the recognition for that expedition, but really it was Frank Worsley, the Kiwi skipper, for those of you who know the story, who really got them from Elephant Island, where all the men were left behind, to South Georgia, and that just continues in that fantastic tradition of New Zealand sailing. I perhaps won't talk more about that in the light of what's recently happened, but suffice to say it's an incredible legacy. Look, this morning I thought I'd talk a bit about the expeditions I've done and some of the things I've learned that I think really are as applicable to organising a polar expedition, if you feel so inclined, as they are to running an organisation or project managing any big vision into reality, and also talk about some of the environmental issues I've seen in the course of my travels north and south. And I think the Arctic and the Antarctic really are the litmus paper of what we're doing on the rest of the planet in terms of change. Just a little bit of background. This is South Pole. I walked there in 47 days back in 1999. The intention was to cross the whole of the Antarctic from one side to the other, 2,700 kilometres. And the mirror ball is not a novelty item. It was put at the South Pole on a pole, literally at the position of the pole itself, to allow scientists to photograph the aurora, the lights at the pole. Before they invented fisheye lenses, a way round it was to take a photo into a mirror ball and you got a curved reflected image of the sky. That was the way of doing it. That pole sits on top of ice 2,900 metres thick. The pole is 2,950 in height. 2,009 is ice, and the actual land is only 50 metres above sea level at the South Pole itself. My expeditions are always unsupported. I'm a big guy. I'm genetically predisposed to pulling around heavy objects, so it'd be no surprise for you to learn that I pull sleds. I put all the food, fuel, comms, spares, everything I need into the sled and pull it. For crossing Antarctica, that's 93 days worth of food, fuel and spares, no corner shops. So you need everything you need to survive in the sled behind you. 225 kilos was the payload for that expedition. And these expeditions are a calculus exercise. Your weight is going down and your strength is diminishing as the weight of the sled and all the things you're pulling goes down with your consumption of the food and the fuel. And you just hope that the food and the fuel consumption weight goes down faster than your strength diminishes over time. Very, very difficult. The principle of the way a sled works is that the weight of the stuff in it puts pressure on the snow beneath it, causes a little bit of the interface between the snow and the runner of the sled to melt, like clenching a snowball and applying pressure and a bit of liquid coming out, and that gives the sled glide. In minus 40 degrees, that simply doesn't happen, and the sled is quite literally a drag across the surface of the ice. As mentioned before, I did lose teeth. I don't agree with many things that Donald Rumsfeld said, but he said there are the knowns, the known unknowns, and the unknown unknowns, and one of the unknown unknowns was really teeth loss. And I went down there, as water expands to form ice, metal contracts, does the opposite, and I went down there having taken a dental kit with me, expecting, in the event of any problems with the dentistry, I could self-administer. Never really listened to the instructions properly. got down there, and of course the molars started dropping out after about a month, principally because they were full of metal filling. And in minus 35 degrees, minus 40 degrees, that will contract. Bear in mind you're sleeping in a tent, which is minus 25. Tents are not warm, they're just a place where you're sheltered from the wind. And I often have people say, look, I've been skiing in Canada, it's minus 35, what's the big deal? Well, the difference is you don't go and drink beers and have a warm meal and a hot shower and then sleep in a chalet, you go and get into that tent. And so you will lose the teeth. It's amazing how far you have to push the needle up into the gums to administer the repairs. As I say, I really wish I'd listened properly to the dentist when we got the advice before I left in Sydney. But I got back and my dentist said, who did this work? It was this terrible array of self-dentistry. And whenever you mention that to sponsors, the checkbooks come out. When you say, look, things have got so desperate, I'm actually doing my own dental work. Some bright spark said to me, okay, you do all your expeditions in the modern way, how about turning the clock back and attempting something like a real man and doing it like they did back in the old days? And so I was living in Adelaide. Douglas Mawson, the famous Australian polar explorer, is from there. And he had undertaken an expedition where both of his colleagues died. There were 3 men. The first one died falling into a crevasse, and down the hole went the sled that he was in charge of with the dog team, and most of the food, 80% of the food went down the hole as well. 500 kilometres from home, Mawson and the surviving guy turned, after a brief memorial service at the lip of the crevasse that had claimed the first guy, they turned and headed for home. Halfway home, second guy died in Mawson's arms of what Mawson described at the time as fever. The guy was in convulsions, soiled himself, and then just expired in Mawson's arms. Ever since the original journey, people had said, how could Mawson have made it with, in his words, 6 miserable dogs, which they consumed, by the way, and 20% of the rations left. Believe me, you lose a lot of weight during these expeditions. I consume, normally on the modern ones, around 7,200 calories a day, which is 23, 24 Mars bars worth of food a day. Normally nothing as palatable as Mars bars, I hasten to add. On the old expeditions, it's lard. It's the sort of white stuff that you leave in the frying pan after you've had you have a big night, you have a fry up and you leave, you don't do the washing up, and that's the stuff you get left with. That's what you consume routinely on these old expeditions for calorific intake. But you're still losing weight hand over fist. I lost 32 kilos in this expedition to see whether Mawson could have made it without eating the other guy. The other guy for me was a Russian. I was really struggling, as you might expect, to find someone to come with me. We didn't ritually kill anyone. At the beginning, we started from where everything went wrong and decided to try and get home from the point at which things went wrong. I needed someone to dramatically die at the halfway point on the way home. And this Russian said, what happened to me in the expedition? I said, well, you have to die halfway home. He said, I'm in, count me in. It appealed to that Russian sense of fate. But it was an amazing expedition, but desperately cold and desperately hard work. And as I expected it would, it taught me all sorts of things about the resilience of those heroic era explorers. You travel in their wooden boats, but were iron men, as the expression goes. Last 3 slides, all about how cold it is down there. If it's so bloody cold, why are we worried about it melting? And the reality is the 2 major ice caps in the world are the one in Greenland and the one in Antarctica. In fact, there are 2 in Antarctica, but essentially it's all part of one big ice mass. The reality is they're not melting in the interior of Antarctica. The principal mechanism by which ice is being lost is the area around the coast of Antarctica and Greenland is warming up to 2 or 3 or sometimes 4 degrees above freezing. And that's resulting in ice at the coast melting. As it does so, the water percolates down through the cracks, hits the bedrock, and acts as a lubricant. And literally the glacial ice is carving off Greenland and the Antarctic more quickly as a result of that process. Greenland is losing 250 cubic kilometres of ice every year from its ice cap, and Western Antarctica even more than that. We've got about 3 millimetres of sea level rise year on year happening at the present time, and very roughly 1 millimetre of that is attributable to thermal expansion, so the water actually expanding due to the warmth, and the other 2 millimetres are attributable to melting on Greenland and melting in the western part of the Antarctic. The eastern part of Antarctica, which is the bigger bit, makes up about 80% of Antarctica, is in a state of uneasy equilibrium. More melting around the edges, being just about held in check by more snowfall as a result of more evaporation from the ocean, which in turn is caused by warmer conditions. So the jury's out a little bit on that one, but certainly the Western Antarctic and Greenland are melting at a tremendous rate. This is me and the guy who I did the crossing of Antarctica with leaving the South Pole, and it was the only point that we actually had a photograph taken with the two of us. It was a bewildered American scientist at the South Pole base who we scared the living daylights out of when we arrived. And we saw him working up ahead of us and approached and literally tapped him on the shoulder, and he wasn't expecting anyone to be coming from that direction. For him, it was middle of the night because he operates on New Zealand time. They get resupplied by Christchurch, so everything is operating on New Zealand time. Myself and my colleague had left from Chile, so for us it was the middle of the morning Chile time. We never bothered to change our watches. Why would you bother? All the lines of longitude converged to a single point at the pole, so what's the difference? And this guy was on the night shift and on his own, and like I say, he got the fright of his life when we tapped him, and then he took the photograph. And he's taken the photo across the tracks of the vehicle, which goes out and takes an ambient air quality measurement from the pole itself, one of many hundreds of thousands of independently verified monitoring points globally, of course. You know, I could talk at great length about the proportions of methane and NOx and CO2 in the atmosphere, but I think it's suffice to say the trajectory is well and truly on the up. We've just passed 400 parts per million of CO2, a very unfortunate milestone to have reached, and methane has gone from 700 parts per billion to around 1720 parts per billion, and NOx similarly gone from sort of 250 up to 315, 316 parts per billion. So all of them are moving up very rapidly. We have the highest levels of these constituents in the atmosphere we've had for about 800,000 years by quite conservative estimates, by other people's estimates. Reading National Geographic as it happens just yesterday, they were saying 3 million years, and they were in turn citing a bunch of peer-reviewed journals to come up with that kind of figure. It always amazes me when people say, well, look, the proportion of what we're putting into the atmosphere relative to natural contributions is very small, between 3 and 4%. And yet, in our everyday lives, we understand the significance of 3 or 4% when it comes to compounding on, say, a house mortgage. Within 20 years, your money is worth half of what it was with 3% inflation. And we take these concepts completely for granted in everyday life, whether it's macroeconomics or our superannuation scheme or our house. And yet when it comes to the atmosphere and the accumulation of CO2 and other greenhouse gases in the atmosphere, we seem incapable, or choose not to be, to recognise the fact that 3% increases year on year constitute a major problem. As I say, within 20 years, that represents a halving of the value of your money if you're looking at 3% inflation. And so a very, very serious situation indeed. The IPCC, of course, have just produced the first part of their 5th assessment report. And, of course, the media in Australia, we've just obviously voted in the Abbott government, which is bad for all concerned. The irony is, of course, that the Abbott government has been elected in largely on the basis of repealing the carbon tax and turning back the boats, when in fact one of the principal drivers, ironically, in the long term for boats arriving is likely to be climate change in Asia. And a very short-sighted policy indeed. But Australians, I can say, as someone who's lived there for 17 years and now have citizenship, are not in the business of making long-term predictions about anything. I'm not saying that for a partisan New Zealand audience, but I think it's really very fair to say that's the case. We are very exploitive of our local environment. Indeed, in Australia. Why are we worried about the melting of Antarctic ice? Well, this shot here is showing my tracks coming out of the screen towards you. This shot was taken about 600 k's from the South Pole. The mountain there is only protruding from the ice by about 150 metres. In fact, it's 800 metres bigger than Taranaki, which I haven't yet seen. The ice here is about 3,000 metres thick. Antarctica is a vast place, 14 million square kilometres. It's about the same, about twice the size rather of Australia, about twice the size of the lower 48 states in the US. I went to India recently. I informed them it was 3 times the size of India. with an average thickness of ice of 2,050 metres over the whole thing. Over 2 kilometres thickness of ice over a place 3 times the size of India, 58 times the size of New Zealand, 52 times the size of the UK, 20,000 times the size of Singapore, depending on how much land reclamation they're involved with. But these figures are astounding. Of all the world's water, 97% is in the sea. The remaining 3%, 2% is in that cap. Of the remaining 1 that's not in the sea or in that cap, a quarter is in a lake called Lake Baikal in northern Russia, hardly accessible to most of us. So 7 billion of us survive on 3/4 of 1% of the world's available water. And yet in Australia, for dairy farming, where I used to run the Murray-Darling Basins project on looking at water use efficiency in the 4 heaviest users of irrigation water, we're using 9,000 litres of water to water grass for cows to eat, to turn to milk. 9,000 litres to produce 1 litre of milk in the Albury-Wodonga region of northern Victoria. Almost 10,000 litres to produce rice in rural New South Wales. We have Victorian-era irrigation canals with the highest evaporation rates in the country virtually, bringing water to sandy soils where the infiltration rates are amongst the highest in the country to grow rice, which we sell to China for about $1 a kilo, and we're using 10,000 litres of Murray water to produce $1 worth of agricultural produce. What we should be doing is drip irrigation for growing watermelons and that sort of thing, but we don't do it. We have a very exploitive principle of the way we operate in Australia. How is most of the ice being lost? As I mentioned before, the principal mechanism is glaciers carving ice more quickly. This is the remnants of the largest iceberg ever recorded to have come off Antarctica. This is photographs taken from the bridge of the boat Aurora Australis, the Australian government ship, when I went down to do the Mawson expedition in 2006. And for some reason, these icebergs are always the size of Belgium. I don't know why. This one is no exception. Thank goodness for Belgium. I mean, it doesn't perform any meaningful role in the European community, but it's very useful as a measure against which icebergs can be made. But the remnants of it are about 80 kilometres long. When I came across it, it was 80 kilometres long, this ice face, about 20 kilometres wide and about 800 metres thick. These are vast pieces of ice. And the world's oceans, they're acidifying too. We've gone from a pH of 8.25 down to 8.14. Again, we have this lack of financial numeracy in the world, or mathematical numeracy, in that a lot of people don't understand the way the pH scale works. Movement on 1 on the pH scale represents 10 times the level of acidity. So a move from 8.25 to 8.14 is a 30% increase in global ocean acidity. I went to a talk and someone said 8.25 to 8.14 doesn't sound that bad, but it is. And it's a case of trying to communicate these things to people. Of course, the acidity affecting directly people's livelihoods. 500 million people globally rely on coral reef ecosystems for fish and food and crustaceans, for shells to form. And on the trajectory we're on with the acidification of the ocean, their livelihoods too will be very much in the balance. This is a theoretical diagram that Hassel's architects who work together with Arup. I'm, by the way, the sustainability guy for a company called Arup, some of the time, when I'm not down in the polar regions. And Arup builds 6-star buildings, wind turbines, electric car technology, that kind of thing. They're an interesting model for a company. They're 10,000 strong globally, but they're owned by 2 charitable trusts, which in turn are owned by the staff. And so there are no growth paradigms. You get your holiday, you get your birthday paid for, and you get the day off. It's very interesting to work for an organisation that doesn't have any particular growth targets. It's a very refreshing business model. But Hassel's were suggesting if we had 3 metres of global sea level rise, where Australian cities might be positioned, and they suggested around the inland sea which would form. Much of Australia in the middle, around Lake Eyre and the large salt lakes in the middle of Australia, are a long way below sea level, 19 metres below sea level, Lake Eyre. It's the largest internally draining drainage basin in the world. In other words, all the rivers go in to the middle of Australia and they never reach the coast. And it's just one large evaporation pond effectively in the middle. But given that 20% of the energy from electricity is required to actually transport it, they suggested that we should position all of the cities around a supply of water for cooling and steam generation for our power uses in the middle of Australia. And obviously this is a complete hypothetical situation, but certainly we should be looking very carefully at what the future holds for our region when it comes to Asian growth. Arup work a lot in cities. We're designing a city called Dongtan, which is a satellite to Shanghai that will take up to 1 million people over a 20-year period. It's a carbon neutral city. And it's designed obviously because there's such amazing growth going on in China and Asia more generally. And we're looking at a situation into the future where of the 9 billion people we might expect to share the planet with in 2050, 4 billion of them might live in the Asia-Pacific region. Many of those people are moving to cities, Dakar, Singapore, Shanghai, Jakarta, all of which are very sensitive to any climate change risks, particularly with sea level rise. The rates of urbanization globally, we need city space for about another 1 million people a week at the present rate. If you've ever been to Dakar in Bangladesh, which is a broken city, essentially, much of Dakar is only about 1 metre above sea level. The rates of migration into Dakar are about 12,000 people a week to a city that's already broken. Those sorts of macroeconomic and macro demographic trends, people moving into Asia, into cities, cities that can't cope, all have repercussions for us here in New Zealand, also Australia in terms of migration. What about the Arctic? I mentioned the South Pole is 2,950 metres thick, 2,900 which is ice. The North Pole is a completely different proposition. You want to walk to the North Pole, it's a journey across the sea. There's no land north of 81 degrees north. So to walk to the North Pole is 1,000 k's across the surface of what you hope will be the frozen Arctic Ocean. In order for it to be frozen, you go at the end of the winter. When in the summer it would all be sea, apart from the last 300 k's in the furthest north. If you went in the middle of the winter, you'd have 24-hour darkness, and it's so cold you wouldn't be able to physically pull the weight of calories you'd need to survive in the sled behind you. You'd have a 300-kilo payload to try and make that kind of journey and sustain yourself with the food you need. So you go at the end of the Northern Hemisphere winter when it is bitterly cold, minus 50 degrees roughly down there. And the journey involves going from one piece of this crazy paving to the next. That's the journey to the North Pole. Unfortunately, the predominant drift of the ice is south, and you're going north, and it's very demoralizing. And you need lots of answers and lots of mind games to play to keep yourself motivated through that. I always think that a trip to the North Pole, if you're trying to describe parallels between life or running a business and a polar expedition, is far closer an approximation than a linear journey in the south, where you, at least each day's achievement isn't eroded away. Whereas, you know, a hard one, 22 k's of pulling a 200-kilo sled up north can easily be erased by the movement of the ice, taking you backwards, and routinely did so during the course of my expedition. It makes it very difficult to measure your effort, because you don't know how long the expedition is going to go on for. And quite literally, a lot of the time you spend treading water, going forwards, being moved backwards, going forwards, being moved backwards. The ocean's about 2,000 metres deep, and the ice, even at the North Pole, is only 5 metres. The Yanks popped up a nuclear sub at the North Pole just because they could, and the Russians, not to be outdone, took an icebreaker and went straight through the ice at the North Pole because they could. And they can break through about 5 metres thickness at the maximum extent. Shipping routes are beginning to open up north. The mythical Northwest Passage over the top of Canada is now very viable as a transport option. And in fact, originally, the Brits trying to find the Northwest Passage, the largest loss of life was the Franklin expedition back in 1845, where 2 big ships were sent with 150 men. They were all never seen again. They still never found the ships and most of the bodies. And they went there trying to find a route over the Northwest Passage, the intention being to get to India more quickly. And the same commercial realities apply today. The Northwest Passage is shorter than going through the Panama Canal by 4,000 k's to get to Asia from Europe. It's a no-brainer that it's going to represent a viable option if the ice melts, as it is increasingly doing. Not only the Northwest, there's another one northeast, and there's even one straight through. It's even shorter again if you go straight through the pole, which again is becoming increasingly viable. A big icebreaker goes first and brings with it a convoy of container ships that follow in behind. And one of the principal things we're worried about up north, we have that melting of the Greenland ice, as I mentioned, up north and down south, but the second major climate impact in the polar regions is really the disruption of the oceanic circulation that's occurring with the melting of this ice. At the moment, as you can see from this shot, most sunlight coming in gets bounced back off the reflective surface of the ice, and it keeps the ocean below it cold. Because it's cold, it sinks. It's also very saline. The gap that gets left behind is filled by water being drawn from further south via the Gulf Stream to effectively fill the gap. It then cools under the surface of the ice, it sinks, goes back down south, and you have a major part of the world's redistribution of heat going on via what they call the thermohaline circulation. With the melting of the ice, that won't happen. The Arctic Ocean is almost landlocked. There's only a gap between Greenland and Iceland and Norway, and then the Bering Strait. If you look at the roof of the world, the Arctic Ocean is surrounded by land on the Canadian and the Russian side, and it warms up like a bath. The more you heat it up, the more it warms, and the less circulation will occur, and the less ice that will form, and you have a positive feedback occurring. Polar bears, I'm not going to talk at great length about polar bear drownings, although that does happen. I mean, polar bears hibernate on land, they come out of hibernation, they're weak, and they really require their food source to be fairly close at hand, and normally the front of the sea ice at the end of the winter when I'm up there. They will chase you. Doesn't matter how infrequently you wash, you still represent a pretty reasonable meal for a polar bear. Bear in mind, they routinely take a 100-kilo seal out of a hole in the ice. They can break the ice with their paws to create a breathing hole. They're very innovative creatures, and the seal will appear and they will literally lift a 100-kilo seal out with one paw. So a 100-kilo guy is much the same as far as they're concerned. I'm not going to talk at any great length about the importance of protecting them, or the fact that a lot of PCBs and other contaminants get absorbed by the fatty tissue. People contain toxins in their bodies in the fatty tissue, so Arctic and Antarctic creatures are particularly susceptible because all the toxins accumulate in the very significant amounts of fatty tissue they have. But I did a talk to WWF recently, and I said, the key thing with them is that not everybody wants to save polar bears. You can't appeal to everybody with the same furry animal kind of message. People can look at it and say, look, it's lovely to preserve them, but you have to speak to industry in language that they can appreciate and they can understand and that motivates them to want to change. You have to make your message different for each audience you're talking to, or you won't get any traction. And that's certainly the case with the polar expeditions I do, which cost several $1 million. If I went in there with the same airy-fairy kind of message to each person about the vision for wanting to do something which is life-changing, it wouldn't appeal to all audiences. To some it does, to some it doesn't, and you have to change your message accordingly. If you want to, if you feel inclined to go to the Arctic after what I've said, and you want some advice on bears, the advice I received on repelling a bear was to try and look bigger than the bear, one guy said to me. The males weigh about 600 to 725 kilos, something like that. Even the females weigh in about 450. They stand, 2.5, 3 meters tall. They're not scared of you. They're territorial. They're extremely hungry. It's very, very difficult to make yourself look bigger than the bear. I took a gun. I've never shot one, incidentally. But the gun I got given when I went on a trip to Russia was an old bolt-action Lee Enfield rifle, delivered under cover of darkness by a cheroot-smoking hunter who cackled as he handed this thing to me, and I unwrapped it from this Hessian sack to reveal the gun with the sort of sight out to one side and the barrel off to the other side, and didn't look like a very promising weapon. And I said to him, what happens if I miss? And he said, my friend, you miss one of them, you deserve to die. Which gave me a certain amount of confidence. But no, they are wonderful creatures and very worthy of respect, but not to be messed with. The best way, I think, to avoid them is to go to the South Pole. And that's obviously what I've most recently done. I went south to retrace Ernest Shackleton's journey. Following the Mawson success, where I didn't have to eat anybody, I went to an exhibition in London called South. It was a celebration of Shackleton and Amundsen and Scott's achievements, and I met Shackleton's granddaughter, and she's not the kind of woman that you say no to. When she asked me to attempt to retrace his famous double, the journey he undertook when this boat became crushed in the ice, in a small boat, followed by a climb across the mountains of the remote Antarctic island of South Georgia. You just don't say no to people like that. I found myself saying yes anyway, and once I'd said yes, things moved very quickly thereafter, and there was no opportunity whatsoever to pull out. I mean, Shackleton is taught these days at all of the top management schools globally, Harvard and INSEAD in Paris and Wharton in the States, for his incredible leadership. I think the world needs a dose of Shackletonian leadership, I must say. One of the key learnings of Shackleton was the importance of setting a goal, putting in place milestones, the achievement of which will get you there. But in the event that circumstances really fundamentally change, having the strength of mind and the will and the conviction to realise when the goal has now changed and to put in place new milestones to get you to the new goal, and just accept that the previous one is no longer achievable. And I think there's a very good lesson there for a lot of post-GFC organisations who set targets for themselves which were no longer achievable after the GFC, and they just held on to them and held on to them and held on to them in the face of the evidence of the fact that things had really fundamentally changed. Anyway, the endurance went down in about 1,000 metres of, or 1,500 metres of water. There are plans, incidentally, by James Cameron and a few others to try and dive on the endurance and recover the plates. Frank Worsley, the famous Kiwi skipper, was the skipper not only of this boat but also of the James Caird. The James Caird was one of the 3 lifeboats that they managed to get off the endurance before it went down. 28 men sheltered and lived under 3 of these upturned lifeboats on the ice for 10 months until the ice gradually moved them further and further north, and they realised they weren't going to get any further north, and they put the boats in the water and made it to an island called Elephant Island, named after the elephant seals that lived there, never been a native population to this day. 22 of the men were left there under 2 of the upturned boats. Shackleton and the 5 strongest, Worsley again the skipper, the Kiwi, Crean, the tough Irishman, and Vincent, McCarthy and McNeish, 3 very good sailors, got together in this boat and did this 1,500 kilometre, 800 nautical mile journey across the Southern Ocean. The boat has no keel. It's a bit like an Australian surf boat. If anyone here has ever done any rowing or any ocean journeys in a small boat, which I'm not expecting you would have, with a keelless boat, you'll realise if you're going down a wave and you get turned slightly sideways, you can get rolled extremely easily, and a bit more about that in a moment as to how long one might survive in those conditions. But we took this boat, we replicated it, and we undertook the journey from Elephant Island to South Georgia, and then we, of course, had to climb the mountains of South Georgia when we arrived, as Shackleton did, with no gear. He had 1 carpenter's adze, so essentially a pickaxe with a flat blade, 30 metres of rope and some of that lovely lard stuff that I mentioned before, pemmican as it was called in those days, to sustain himself, plus albatross eggs they'd nicked and seals they'd managed to cull and flesh from them. This shot actually is taken at the same point. We did this journey using traditional navigation, sextant, chronometer, same Thomas Mercer chronometer as Shackleton had used. We used all the old Burberry clothing. Burberry these days make tartan-lined handbags and things like that. In the old days, they made all the polar gear. So if you wanted to do a South Pole expedition, you would wear a Burberry outer. Shackleton, Amundsen, Scott, Mawson, they all wore Burberry, very stylishly. Terrible clothing, I can tell you. Keeps the wind off, but chafes, has no insulation capability whatsoever. And despite having spent 10 days on an Antarctic base coating this stuff with animal fat, as Shackleton did on the original, just to make it more useful for a boat journey, the first wave came in and I was completely soaked through and remained that way for the remainder of the journey. I'm convinced there is some application for that technology. I'm just not quite sure what it is. How does one do these expeditions? They take 4 years of planning. This one is supported by Discovery Channel in Europe and PBS. HarperCollins are the publishers. They all tipped in a little bit of money. We had sponsorship from various others, Intrepid Travel and Arup and a few others. But I think the how really is about having a vision that you want to do something like this, and then again, putting in place those milestones, the achievement of which will get you there. A goal is just a dream with milestones, as they say. And that's very much the case with this. And it's not easy when you're married and you have children and you're trying to pursue a career as an environmental scientist and you have a mortgage to pay and you have bills to pay and logistics to manage your everyday life. These big vision items don't happen easily. You must lock them in and pursue them, sometimes at the expense of all else. I saw a time management consultant give a lecture to a group very much like this in the past, and he produced a glass jar. If anybody has heard this metaphor, it's a very good one, I think, for this idea. And this glass jar was full of rocks. And he said to the audience, "Is the jar full?" And somebody said, "Yes, it looks full." And he said, "No, produce gravel." Gravel fills the space between the rocks, filled it up to the top, and he said, "Is the jar full?" Someone said, "Yes." He said, "No." Sand, water. By the end, the jar was well and truly full. He said, "What's the message?" Someone said, "Well, you know, the jar is obviously your life. Harder you try, and the more you can fit in." He said, "No. Key thing is get the big rocks in first." Big rocks are those big vision items that one wants to achieve, whether they be the achievement of the whole expedition, trying to do something about climate change, trying to do something about resource allocation, and then the milestones you put in place that will get you to the achievement of those things in the end. Expeditions, without going into too much detail, they're all about critical path. Critical path says, you know, you have a deadline by which everything must come together, and there are certain milestones need to be achieved along the way to make that happen. Some of them can slip, some of them can't. The ones that can allow them to, the ones that can't definitely don't allow them to. And ones that if you bring them forward a bit will accelerate the achievement of the whole thing, do them a bit earlier than you would otherwise. And in the course of this expedition, the one thing that wasn't actually very important was the boat. You know, you need the logistics and the people and the team and the risk assessment and the funding to be aligned, and the film broadcaster. The boat is something that takes 6 months to build. You can build that in the final year of a 5-year planning process. But I felt for the purposes of morale, particularly mine, it was very important to actually have the boat progressing so that people could see tangible evidence we were actually moving somewhere, because many of our milestones, very much like trying to do something about a broader issue like environmental change, you know, chipping away at improving the tightness of illegal regulation to prevent loopholes or whatever that might be, are things that are often very intangible, and you work away for years on them without seeing any real evidence of change. And so it is with these expeditions, a lot of intangibles. The boat represented a tangible manifestation. Everything was moving forward for us, the broadcasters, the sponsors, and the team, and it was very, very important to do that. The team were a very high caliber group. Again, I could talk at great length about the importance of complementary skill sets and all of that good teamwork stuff. But at the end of the day, the key thing for me was that the team needed to know the team came first. I didn't want any prima donnas. You're in a very difficult situation with these expeditions where you're trying to recruit absolute top caliber people, but they can't bring their egos with them. You need people who are going to be team players. I had 3 sailors and 3 climbers. I'll tell you who they are in a sec, but three sailors, 3 climbers. The idea was the sailors would get us to the island and the climbers would get everybody over the island. But I needed people who knew the team came first, because at the end of the day, the 3 climbers would be the ones who strode triumphantly into Stromness whaling station, where Shackleton reached all those years ago, and the sailor's role could never be forgotten, and they needed to know that that was the case. I didn't want people who were gung-ho. I had about 200 CVs from international sailors saying, "Look, mate, you get me to the start, I'll get you to the finish, don't worry about the rest, you're not a sailor, don't worry, you concentrate on your stuff, I'll get us there." I wanted people who were fearful, and the guy second from the back, I'm right at the back, Nick Bubb, he's a Volvo round the world sailor, he's in his mid-30s, he's a Brit, and he said to me, "Look, this is crazy, can't work for 4 or 5 really fundamental reasons, come over, we'll discuss them." And I didn't mind that. I wanted people who were fearful, respectful of what we were going to do, but still chose to come. That's the kind of person I wanted, like the Russian. And he said, "Look, this is what we can do to try and mitigate some of those risks." I didn't want employees, I wanted owners of the expedition. People who really took ownership of their component parts of the expedition. Paul Larsen is the next guy. He's the fastest sailor in the world. Broke the record, his own record, in November last year, 65.4 knots. In a boat very similar to the America's Cup boat, albeit narrowed down. I was listening to the radio yesterday and they were talking about Paul Larsen being the person who's pioneered that kind of technology, the kinds of boats that are now being raced in the America's Cup. He's got 7 world records, fastest across the Atlantic, fastest fastnet race back in the UK, and a whole series of other things too. Seb Coulthard, the next one in the black beanie, He fixes helicopters, the Royal Navy, but I felt that the skill set of making helicopters ready for different theatres of combat, which is his role, Bosnia to Iraq to, different camouflage, different air intakes, different munitions, with 10 days in which to do it. I thought that skill set and that ability to improvise and think laterally was perfect for working on board our small boat. Because in addition to building a replica of the James Caird, 100-year-old whaler, we had to film this thing for Discovery Channel. Only thing that stopped it tipping over was ballast, by the way. Shackleton's case, 1,000 kilos of rocks from Elephant Island. In our case, 600 kilos of camera batteries. Equally uncomfortable to sleep on, I can tell you. And about 400 of rocks that we brought with us on the bottom of the boat. Barry Gray, he is the head of outdoor survival for the Royal Marines Regiment in the UK. And as far as I can gather, his role is to take 200 raw recruits and reduce them down to about 10 people who get to join. I don't know what happens to the others, but he was a perfect guy for this, probably. The key thing was I needed to understand all of these people and understand what their motivations were, because not everybody's reasons for participation towards achieving this common goal is the same, and you need to understand what their reasons are, because it's fine when you're sitting in a media conference talking about, we're all a great team. When you get down there and the divisions start to appear and the pressure is on, you need to understand what the individual motivations for the people are to make them want to pull in the same direction towards achieving the goal. Very much like the environment movement in which we're involved. Not everybody's motivation is the same. The guy at the front, Ed Wardle, is a legendary cameraman. He's a Scot. He survived out on his own in Alaska for 50 days, just with a penknife and a Snickers bar or something. He's also summited Everest twice, and he is the former UK free diving champion. In other words, hold your breath, go as deep as you can. I always maintain that last one was a very useful skill for the journey we were going to undertake. But a crack team of people for the journey. And, the journey was extremely challenging because you're wet the whole time, you're mildly hypothermic all the time, you're seasick all the time, and you're traditionally navigating, so you really don't know where you are until you can see the sun. We saw the sun twice, like Worsley. What I'll say immediately is that Worsley had far worse weather than us, didn't have 22 men left behind on Elephant Island, and no one knew they were there. So he faced significant problems that we didn't have. So I would never stand here and say we did exactly what Shackleton did. We got as close as we could in the modern era without eclipsing that which Worsley and Shackleton achieved. I don't think anybody can ever do that. But we knew our risk assessment was 171 line items in an Excel spreadsheet. I allow fear to just play the role it needs to in things. Fear is a very good driver of a very realistic assessment of risks. No point just brushing things off. And so we were very open about what would happen if someone fell overboard. We have no capacity to turn round in a boat with no keel, by the way. The current takes you at about half a knot an hour from west to east. The current coming round the bottom of South America is about 3 times the volume of the Gulf Stream and runs west to east at about half a knot an hour. There's no way known you're going to turn around in a keelless boat and push back into that current. You're just going to go that way a bit more slowly by trying to turn around. Survival time in the ocean is about 10 minutes. We did all the testing. There's a lab in the UK run by a guy called Mike Tipton, Professor Mike Tipton, who specialises in cold water immersion. That's his game, seeing how long you can survive in very cold water. And Ed lasted the longest, just over 10 minutes before he sank. Frogmen obviously come and take you out and warm you up. But essentially, you don't go into cardiac arrest or have any more serious physiological problems. What happens is your muscles stop working. You just sink. That's it. We learned a lot of things about drowning on this trip. Do you know that when you're plucked out of the water, you're not deemed to be a survivor if you've fallen in the water at sea until 24 hours after you've been plucked out of the water? Because one of the principal things that kills people is drowning from the inside out. In other words, you inhale salt water, it gets into your lungs, and osmosis does the rest. Fills your lungs with your own bodily fluids, trying to reduce the salinity in your lungs from the seawater you've inhaled. You can be lying in bed, in a hospital bed, breathing and talking and still die. So very, very challenging. Biggest risk was capsizing, one guy ending up in the water or maybe two. We were steering with ropes, like Shackleton, so in a storm you've got a tiller, no tiller rather, just a helm, but you're pulling with a rope, a hemp rope, left to go left, right to go right, which is useful for a non-sailor. And sometimes two guys would be on deck having to pull the rope in unison, just to have the strength to move the boat. Three other teams had attempted this before us. We made a lot of did a lot of research in learning what had gone wrong for them, but we only used what Shackleton had. With no self-righting technology or modern equipment or modern navigational aids like the other trips had used, and none of them made it. The best we could come up with when upside down with someone in the water in order to rewrite ourselves was to deliberately flood the boat by opening the mushroom air vents on the deck, allowing in what we reckoned needed to be 400 litres of water, and then the hope that a big wave would push all that 400 litres of water over to one side of the boat, and then combined with the weight of the men still below deck, we could get enough momentum to try and flip the boat back over. But it wasn't a very very reassuring thought. You need a very philosophical attitude to problems. And I really believe I bring those to my day job, and I bring them to the environmental movement, really. I mean, I look at challenges and problems as things to be overcome. I break down the enormity of the task into manageable pieces. I think the Dalai Lama said there are two types of problem: the ones you can overcome, in which case don't worry; the ones you can't, in which case don't worry. You can have that philosophy too, of course. Mine was all about learning from problems and convincing myself that it makes me a better person having experienced the problem, having overcome it. The problem in this case was a Mawson, that's the Mawson replica tent. When the guy went down the hole with the food and the dogs, the tent went with him. What Mawson and the surviving guy were left with was just an old cover. They made a pyramid frame of a couple of skis and a couple of sled runners, slung the piece of fabric over the top and weighed down the edges with snow. That was their tent. So it wasn't a proper tent. And we did the same. And I was sleeping on the surface of the snow in my reindeer skin sleeping bag, eating my 2,000 calories a day. I eat about 4 just normally, so 2 is woeful. I'd finished the food by about 10 a.m. My lard biscuit about the size of a mobile phone, a couple of sledge biscuits, 5 boiled sweets, a cup of sugary tea, and a bit of kangaroo jerky as dog substitute. Our backers wouldn't allow us to eat dogs on the trip. And you're lying there on the surface of the snow and your body heat escapes, melts the snow beneath you, makes you wet. But when you get out of your sleeping bag, roll it up, stick it on the sled and pull it around in minus 25, of course it freezes. And then when you get back in it, the only thing that makes it malleable again is your body heat, at which point you're wet. And so you're on a very, very serious downward spiral. So you need a very philosophical attitude to problems, and I do literally carry it into my day-to-day life. And you need resilience. For all the clever management techniques and milestone setting and goals and capacity for lateral thought, you still need a bloody mindedness. And my role as leader of the expedition was to make sure that people's reasons for wanting to be involved were the right ones, and that it was going to be enough to get them through the toughest moments of the expedition. This is Paul Larson, one of the most resilient, upbeat people in the team, but it wore him down too. Just the sheer cold and unpleasantness of being completely wet, mildly hypothermic, constantly seasick, and having the responsibility of being our principal navigator for the expedition. So you really need people, you need to understand people's motivations for whatever the journey is, whether it is something to do with the environment and trying to realise important milestones in the environment, or an expedition like this. This shows 3 things. The red map going from bottom left up to top right is Elephant Island to South Georgia. This is the journey that the James Caird did, 800 nautical miles. And Worsley is the W in the Union Jack there of the Shackleton expedition. That shows the route that Shackleton took. Ours was the route in green. The route in yellow was what we thought we were doing at the time, because bear in mind we were traditionally navigating during the course of the trip. So we only saw the sun twice, like Worsley. The rest of it was dead reckoning. We just tried to keep on the right bearing for our final destination. As I've said before, I don't agree with Donald Rumsfeld about many things, but I do like the known unknown, and the unknown unknown analogy he uses. I think for us the knowns were size of the boat, people in the team, distance we had to cover. Known unknowns were things like what the weather would bring, injury, that kind of thing. And the unknown unknowns were things like rogue waves. And of course, Shackleton experienced a rogue wave 444 miles into his journey, about halfway, came out of nowhere. And we thought these things were mythical until North Sea oil platforms began recording these occasional waves, which are twice or three times the size of the rest of the surrounding sea. And again, without stretching the bow too far, I think this is the situation in which we're faced with the environment. We know when it comes to an issue like climate change, the knowns, we know the trajectory we're on, we know the number of people that we're likely to end up with. The known unknowns are things like the extent to which, as a global community, we're prepared to curtail our activities and reduce the amount of carbon we put into the atmosphere, reduce the level of land acquisition from the natural world that we're currently doing. And the unknown unknowns are things like the Thwaites Glacier in the western part of the Antarctic, that, you know, these things are not linear. We could end up with a situation where there's a sudden cataclysmic loss of ice off the western part of the Antarctic ice cap if we reach a particular tipping point. It's not just a gradual, steady, linear reduction in ice down south. We reached South Georgia in our small boat, and that was one of the most terrifying bits of the whole expedition, because in a boat with no keel, as I've said before, you can't go back into the wind. If the wind is blowing you directly onto the rocks, you end up what they call in sailing parlance a lee shore situation. Wind's blowing you onshore, you've got no opportunity but to go onshore. You can try and turn round, but going back into the wind, you're just going to be pushed backwards anyway, because you have no keel to lock you in. And the cliffs are about 250, 300 metres high. And we had a situation where we had to make the weather we got fit the journey that Shackleton did, whereas the journey he did was defined by the weather that he got. And so ours was different. We were force-fitting our expedition with his expedition to our weather. And it comes down to managing expectations of the team. We had 6 of us. 3 of the men on the boat got trench foot, which is like a frostbite type condition. They were forced to drop out. We had 2 Discovery Channel camera people who travelled in a separate boat, theoretically our backup in the event that we'd sunk at sea. Realistically, they were on a yacht. Chances of them coming to our rescue were virtually 0, but nevertheless, that provided them with transport to get to South Georgia. We set off with them and the 3 remaining guys on the trip, me, Barry Gray, the Royal Marine, and Paul Larson, the navigator. Interestingly, the same combination as Shackleton had had on the original expedition. The navigator, the hard man, Baz, was the Tom Crean of Shackleton's journey, and I was the leader of the expedition. And the 2 Discovery Channel cameramen, the first guy injured his back, shall we say, 3 hours in to the journey, coincidentally very near the one possible evacuation point that we'd established on the island, and so he had to be evacuated by us in the old gear in a blizzard. And the guy, his other cameraman who was to be roped to him, decided that he too had a young family and didn't wish to risk it. So unfortunately, within the first 4 hours, we lost both the cameramen, both of whom had worked on an Everest show and had a very impressive CV, but you can't believe everything you read, of course. And but certainly with my guys, I prepared them for the fact that this was going to be awful. You don't retrace the greatest survival journey of all time, according to Edmund Hillary, and expect it to be a kind of walk in the countryside. You know, it's going to be terrible. And we had 85 knot winds and 0 visibility and lots of crevasses. Shackleton crossed 3 glaciers in his crossing of South Georgia. He was the first person, together with Worsley and Crean, to ever do the trip. And because of climate change, the 160 glaciers on South Georgia, 97% of them are in retreat. And certainly the 3 that he had to cross, we only had to cross 2 because the other one's gone, quite literally, the Koenig Glacier. And the crevasses were very, very difficult, very awkward. That's the Koenig. I realised I'm going over time. We finally walked into Stromness whaling station after this incredible effort. Stromness is one of 5 whaling stations on South Georgia. They're all closed now, but back in the day, 175,000 whales were culled just from those 5 stations. The largest ever blue whale was taken at the whaling station just around the corner at 33 metres. It's amazing. Why do I do it? I get asked 3 questions more than any other. Are the ice caps melting? I've made some reference to that. How do you go to the toilet at the South Pole? Is the next one. Board members, kids, they all ask the same thing. The answer is quickly. Why? I do it because I'm fascinated with discovering what I'm capable of. That's the best I can come up with. I find I'm in the company of a more resourceful part of me when I'm down in these places. That keeps me going back to want to re-experience it. But more than that, it's about having a vehicle to talk about environmental issues, where you go and talk to a board. The majority of the people in the board are 50-something white males, I'm afraid, and they respond quite favourably to messages about teamwork and motivation and leadership. And then you pitch your environmental message by stealth on the back of a good adventure story. And Shackleton, probably leave the last word to him. A journalist said to me a while ago, what's the main difference between your expedition and his? And I said, well, Shackleton was trying to save all his men from the Antarctic, and I'm now trying to save Antarctica from man. And that's got to be a very unfortunate irony, but thank you.